Alright, so I've got a new project I'm working on. I was talking to a friend of mine recently doing a Coyote 50 swap, and we were talking about how there's not many options for an instrument cluster. I generally work with Toyota stuff pretty extensively with CAN, Communication Area Network, and so I told him we need to get a hold of some Ford ECUs, see if we can get them connected, see how they communicate. So this is part one of that project. I picked up a 2015 Mustang instrument cluster, and the thought is if we can understand how it communicates, you can integrate it into a Coyote Swap, say using like a Ford Performance control pack or something like that. Obviously, majority of the ECUs of the network won't be there, but you'll have like the PCM, and it's about, can we simulate commands from the body control module and other ECUs that this ECU, being the instrument cluster, would expect to see on the network, and get it to where the instrument cluster will function on a swap in, your resto mod or whatever vehicle, without having the entire rest of the ECU network in the vehicle, like the factory Ford vehicle there. So anyway, so I'm going to kind of go through this a little bit. Interestingly enough, this instrument cluster, like I said, came out of a Mustang. It's on the bench right now. I have it powered up. There's about 6 wires, power, ground, CAN high, CAN low, which is the communication area network, which pretty much controls everything on this. And then there is the fuel level input, which is a 2-wire input of a variable resistor, just to get the fuel gauge to work. So it's powered right now with 12 volts on the bench, and interestingly enough, when you power it up, it doesn't actually boot up. So the ECU has power, but it's not lighting up, it's not functioning. So Ford, in their clever wisdom, has a wake up command that must be sent via the network from the body control module to get the instrument cluster to come on. So I've created a little GUI trying to stitch together in the video on my laptop. So I'm going to send signals from my laptop via an Arduino based CAN controller into this instrument cluster to simulate the signals of the car, like if it was running in the car. So if we click this ignition button on, we can get it to boot up, and then I generally turn the backlight on too so you can see, and we're immediately greeted with a whole host of errors. ABS warning, check engine light, all kinds of flashing indicators on the LCD, because it's looking for signals from, say, the ABS ECU, the body control module, to say like these sensors are there. And if it doesn't see anything, it just defaults to thinking, oh, it's broken. Low engine oil pressure. We're not seeing anything from the PCM, so we assume it's broken. The door jar thing, it's not seeing a signal from the body control module to know if the door's open or closed, so we just assume it's open. So that's a real problem now, because you can power it up, but you get almost no functionality because it's throwing error after error after error. So we're going to see if we can simulate these commands to basically make the warning go away. You spoof it. Can I feed it a signal where it thinks the doors are closed from the body control module? So if I go down the list of my little GUI here, I can turn off some of the flashing warning lights. So the check engine light, there it goes. ABS warnings, off. Park brake indicator behind the RPM gauge, off. Airbag warning, off. There's a battery indicator warning there in the middle of the LCD with a little plus minus sign. Turn that one off, it's gone. Door jar, oh, now it thinks the doors are closed. There is a LCD message about something with the steer. That one's steer fault. We can turn that off. Tire pressure warning, now that's gone. And the C manual one and the tire pressure faults are still there. You can see the wrench. I believe that has something to do with the throttle position sensor and the PCM input. I'll figure those out. But anyway, so now we at least have an instrument cluster in like an idle state in the car. with all the warnings turned off. We're simulating most of those to keep them suppressed, if you will. Ford's really cool because we can control the LCD and the steering wheel buttons with Communication Area Network, or CAN, which is running all of this. All of these are CAN messages. So I can move up or down and, you know, select the menus back and forth, whatever. That's really cool. The gear selector at the bottom, we're in park here. We can switch to reverse, neutral, drive, or go into the shift mode. When we pull up the shift mode, I programmed it up where it'll show what gear we're in. So first, second, third, fourth, fifth, sixth. We go back to drive, the gears disappear, back to neutral, back to reverse, back to park. So you can get all that working. This is all digitally driven. So what about some of the gauges maybe? Obviously the biggest one would be the speed. So I can maybe increment that up in 5-mile-an-hour increments. Let's go all the way up to 90. So there's speedometer at 90. We can keep going all the way to 160. I'm clicking through this as fast as I can in increments of 5, and it's updating pretty quick. So that's pretty cool. It's even faster. We'll talk about that a little bit more later. Same for the RPM. I can jump it in groups of 500 or literally any value between 0 and 8,000. I just increment by 500 because it's easy. So let's go 2,500 RPMs, and maybe we'll bring the speed back up to 65. Coolant temperature under the RPM gauge, let's bring that up to like, I think about 200-ish, maybe 175. The gauge on this is kind of slow. You can see it slowly creeping up. It's interesting how they program those. It's not linear like the RPM gauge or the speedometer. So that's like 175-ish. We can bump it up to 200. It should move more. It'll hit a little bit of a dead zone, and then when we bring it up really high, we get an over temp warning. So I'm gonna bring it back down. We'll keep that warning off. Let's see some other cool things in the gauge mode. So spend some time messing with this. When I bring the ignition command on and the wake up signal, we can get some other really cool gauges here. You saw the distance DMD. It has some fuel mileage in there. The fuel gauge is reading about a half a tank from the variable resistor. Let's start with trans temp down here. So there's our trans temp on the default value. I can start bringing it up. There's 100 degrees Fahrenheit, 125, 150 to 225, getting pretty warm. There's a little bit of a rounding issue because almost all of this stuff is sent in Celsius. So we'll move up now. Let's look at air inlet temp. Same kind of thing. This is air temperature at the intake. Air fuel ratio can go 0 to 20. So we can control that. Boost. Got it in PSI, and I'm just showing positive pressure, 0 to about 20 PSI. I think the range is actually more. And there's even a cylinder head temperature, you know, we can do that. And then you can kind of go into one of these gauges with the enter button and see, you know, as we move it, the actual needle will move too. So, those are pretty cool. There's an oil temperature one where you can get that to go from low to medium to high, I believe. There's the voltage, distance to empty. I could do tire pressure. I didn't program that into this GUI, but I have the messages for it. It's not super important right now because most of the resto mod swap guys aren't going to be running TPMS. So we can look at trip fuel. That is the trip information that was in the cluster when I got it. Trip 1, I reset this one, so there's been no miles driven. It thinks there's 185 miles to empty based off the fuel tank level, and it's averaged out mile per gallon. We could run all this. I didn't incorporate it yet into the GUI, but we could do that and have all those work with signals from the PCM. Not much really here in the settings, some alarms, stuff like that. So pretty cool. We're making really good progress. I've only been working on this about 2 days now. So the one thing I really want to mention and why I think this is an important topic, we were talking, my friend is doing the 5.0 swap. Almost everybody seems to be running like the Autometer gauges or Dakota Digital or like that aftermarket LCD. I've seen the Autometer one. It works, but if y'all ever notice, it's incredibly laggy because they're using the OBD2 protocol, which is designed for diagnostics. And in OBD2, you can go and request from the PCM the RPM value, and it'll return it to you. You have to go ask for it every time. Well, when doing that, that means you have to use the OBD2 command, or the PID, a lot of people call that, and go ask the power control module every time continually, what's the RPM, what's the RPM, what's the RPM, and wait for it to answer. And it can do it, but it can't do it fast enough to keep up with the gauge. And that's why you'll see a lot of them that are really laggy. It's really slow. You know, I saw a guy one time on YouTube, he would hit the accelerator, and about a second or two later, the RPM gauge would start moving. When you know the actual broadcast message from the PCM to the cluster, like what I'm using here, it's incredibly fast. The refresh rate is so much better. So I created these sliders down here because I can slide left and right now and control it much faster than I can with just these rolling checkboxes. You can see it, the RPM gauge kind of up and up. But if I come, so I'm going to take it all the way back down to 0, and then I'm going to come on this slider and I can just flick it all the way. And you can see how fast it moves, just back and forth. So with communication, you know, if you get the message format right and the timing, these refresh rate is like really, really good. You'll get almost no lag. And we can do the same for the speedometer. I did a little slider for it. So all the way to 160, all the way back to 0. You know, it's doing the full sweep very fast, and almost any value in between. So that's pretty cool too. I think that's probably a really good overview of everything so far. What this would prove is that, yes, with a little bit of work, you could build a microcontroller based CAN gateway that basically mimics or simulates the body control module, the ABS control module, and all these modules from the network that are missing. And so if we get the instrument cluster in this state, say in, you know, and get it installed in a vehicle that's got a Coyote Swap running just a control pack, and if we can pick up the broadcast messages on the CAN network from the PCM, we can run the RPM gauge and the speedometer, and it will have like a really good factory look. So this is part 1 of that project. Part 2 is probably going to be getting the PCM up on the bench, get it powered up and log it, and then we'll see how we can merge the two together and build a kind of like man-in-the-middle interface. So I think that'll be all for now. I'll try to keep you guys updated in the future.